Hello, I'm Nick Holt and welcome to our latest AMS live stream. Today we're going to be discussing the challenges, solutions and opportunities around designing and manufacturing electric vehicle architectures in a flexible, sustainable and scalable way. And there's an increasing mix of ICE, hybrid and electric vehicles now being produced across manufacturing operations. And this is placing greater pressure on manufacturing engineers, production teams and suppliers to find the best way to optimise design, production of bodies and components and modules. And especially with an eye on emissions, energy consumption and waste management. And also trying to enable the most flexible manufacturing solutions and also combining that with the need for streamlined supply chain processes. So this live stream is going to focus on materials, technologies, processes to improve sustainability and modularity in the production of the automotive body structures and some of the major components. Discussion points around this that we wanted to pick up on were around sort of design for manufacturing, sort of innovations in the body architectures and modules. The importance of design for manufacturing has always been there, but is growing, and the connection between that and the actual final production of the vehicle is much closer and much more combined, intertwined than it ever used to be. Also, with the body structures, we're seeing a different array. Many manufacturers are doing mass production with unibodies that look very similar to the ICE vehicles that they looked at from the surface. Certainly, underneath they are quite radically different. And then we're seeing other skateboard type platforms which are coming through, which allow massive flexibility in wheelbase and track, and also what kind of body you put on it and what the vehicle could be utilised for. And then also strategies for increasing flexibility and scalability. This is a problem. We're dealing with a variation of platforms, componentry, and also of volumes. And this is placing greater pressure on sequencing and the way lines are designed, dedicated lines, multi-platform lines. So we're going to have a little chat about that and see where some of the trends are, see where we think that the processes might be improved or optimized. And sustainability is an actual given part now of any production process. It's always been important, but its importance now is right to the fore. So car makers now, every aspect of the vehicle that they're looking at has to have an audit on its carbon footprint. And similarly with materials, processes, and this works all the way through to the supply chain as well. So we're going to have a look at that. And automation and digitalisation to improve body module production. I mean, digital tools are a key factor now, and the more we talk, or I talk to manufacturers, to suppliers, to equipment suppliers and system suppliers, they're invaluable. They can't remember a time when you didn't have these tools, and the challenges of trying to do the transition across to electric vehicles, to e-mobility, seems that it wouldn't be possible in quite the same, or be viable even, without this advance in digitalisation. And that goes hand in hand with automation, and there's been some big advances there. So before we get started, I'd just like to thank our sponsors, Magswitch, for supporting us with this live stream. Greatly appreciated. They've been a long time partner with us for numerous events. So thank you for their input to this. And to get more insights, you're not just going to have to listen to me blabbering on about this. I've got some genuine experts joining me now. I have Peter Dow, who is Vice President of Engineering at REE Automotive. Peter's worked in the industry for 25 years, earning an MS in Industrial Engineering and a PhD in Mechanical Engineering. Since he graduated, I'm not going to ask him how long ago that was, he has worked at global automotive consultancies, technology startups, and automotive OEMs and tier ones, including Ricardo, Lotus Cars, GetTrag, and Tata Technologies. My second guest is probably no stranger to many AMS audiences, Cengiz Kiltkan. He is President of Global Sales, Automation, and Executive Director at Europe for Magswitch Technologies. Cengiz has a huge amount of experience which we've drawn upon in the past. He has been working with Magswitch since 2012 and established the European subsidiary in 2013. He started his career as, I've got it written down here, as a proposal engineer, and I know he was heavily involved in body in white and body production, so he has a great deal of insight into this, and his subsequent role with Magswitch has furthered that as an equipment and system supplier into major OEMs. So if I'd just like to welcome Peter and Cengiz onto the screen, so we can just say hello, so make sure that you are actually here.
Oh, yeah, hopefully you can see me. Hi there, everybody.
Zooming in, Peter.
I'm zooming in, yeah.
Cengiz, thank you both for joining us. Just as a quick note, Cengiz is not in his own office. He's hijacked one of Volkswagen's offices. I think it's Hanover, your Hanover plant. Is that correct? You won't tell us why he's there, but it's something to do with body shop. So very apt at the moment. So thank you for taking the time and joining us. Just a quick message for our audience. So before we begin, I'd like to invite all of you to send your questions to the panel, which we will ask during the discussion. So if you pick up on something, you want some clarification, you want to ask them something, please do drop those in. And you can do that by typing your question into the chat box, which is in the bottom right-hand side of your screen. And similarly, if you're experiencing any sort of technical issues that we might be able to help you with, put your questions in there and our team here will hopefully pick those up for you. Right, enough of me and the introductions, let's get started. So one of the areas I think I wanted to sort of touch upon, and we've got quite a contrast here in some respects. Peter, working with REE, your vehicle architectures actually start with a corner, I understand. So the technologies that you have, looking at the car architecture, we generally just think of the body in white, but actually the architecture goes beyond that into its powertrain, suspension, and its electronic control systems as well. And that is all now a great part of the vehicle manufacturing challenge, and that's something that has to be considered across the board. I mean, would you like to give a bit of insight into how REE have been developing that?
Yeah, very much so. So REE Automotive, as you said, we're very much based around the corner technology, which is that allows all of the drive, the steering, and the braking to be contained within the corner itself. That allows you to have a steer-by-wire, brake-by-wire, and drive-by-wire functionality, and that kind of unlocks the opportunities with vehicles, and particularly with the bodies, because it allows you then to position those wheels really where you want. You can look at, like you said at the start of the podcast, different wheelbases, different tracks. And in doing that, we then provide platforms that then are kind of configurable for different applications. So you can very much provide bespoke solutions in smaller volumes for customers. Particularly, we're targeting first of all the kind of commercial truck world, but that platform application then I think unlocks a world of opportunity for the upper body.
Right, we're going to come on to it a little bit later, I think, about sort of complexity around this. But it's a very interesting concept, and EV is well, the LCV market has been picked up quite quickly, and there's a lot of focus from I hate to use the term startups now because companies like REE have been around for long enough now not to be called that. But it's the newer car makers certainly are picking up on this, and certainly with the kind of platforms you're describing there, that seems a great fit for those kind of delivery light commercial vehicles.
Yeah, and I think the key point there is that the light commercial truck world, vehicle world, has some great use cases for EVs. You know what they're going to do. A lot of them are going to be delivering goods, delivering people, have a set route, have set depots that they start from that allows you to have all the charging structure, etc. But then with that, people want them to be very much bespoke or configurable for their application. So, conventionally you buy a kind of a chassis frame or a cab chassis off an OEM, and you put different top hats or different bodies or different structures onto it, but you're constrained by what you get from the OEM. What we're trying to do, and what this allows us to do, is to have very much tailored products for our customers to allow them to deliver to their customers, much more efficiently. They can have the size of battery that matches their application. They can have the stepping height that allows them to have different kind of passenger types in. It allows them to have more maneuverability in a city, so that they can actually get a bigger vehicle into a tighter environment. It unlocks, and I think like I said, from the body perspective, it unlocks the amount of opportunities and different configurations really that you can apply with that.
Thanks, Peter. And coming to you, Cengiz, I mean, you're obviously at Volkswagen. We just mentioned that earlier on. And here's the thing: when you look at if you take cars that have been basically cars that are existing models, the Golf, Polo, things like that have been existing platforms or ICE platforms that have been transitioning from that to hybrid and then to full electric. Obviously, now we're seeing with Volkswagen, especially, we're seeing the ID range. So we're seeing bespoke vehicles. But those vehicles that are still in production, that all the tooling is there for, underneath the structure has to change. Floor plans have to change, bulkheads have to change when you're moving from ICE to hybrid and then obviously into full EV. So that's a big challenge for body shops. You add in a great deal of complexity around what was probably a fairly fixed model. So what's your sort of perspective on that transition, and also maybe where you're seeing the skateboard platforms that Peter was discussing there sort of coming into it?
Yeah. So as you mentioned, light commercial vehicles is also the focus of today. There's also a huge option variety available, as Peter mentioned, to the end customer. And this is making the body shop, as you mentioned it, really complicated. And this is where we are looking at. We are looking at from really 30,000 feet in order to accommodate as much as we can old technologies with newer transmission technologies. And the biggest challenge what we are seeing is not necessarily on the tooling side, but also on the joining technologies, which comes with the lighter materials, with different structural materials, etc. Having said that, of course, still a big challenge, a continuous challenge, is to accommodate multiple platforms as well as multiple upper bodies in one manufacturing line in order to scale and match the needs of the market. And this is where we are jumping in with our expertise in layouting and process designing in order to really make it possible for our customer base.
One of the things you're looking at, I mean, market demands and trends are kind of rapidly changing now, in the sense that, I mean, one of the things that we quite often hear around new vehicle production is speed to market. Now, I could be hazarding a guess, an average time for an ICE vehicle quite a few years ago would be about 5 years from concept to production, maybe, let's say. But these days, that's been about halved now. So that puts enormous pressure on all aspects of the vehicle manufacturing operation. Peter, coming back to you, you mentioned there creating kind of bespoke vehicles at relatively low volumes, but it's not just a case of there is more to it than just kind of bolting a body on top of a platform. There's a great deal that goes in at the back of that and creating that architecture. So where are the complications and the challenges around that from your perspective?
So I think you're right. Getting some to market is, I think maybe the thing to mention as well is that there's a real pull in the market as well for EVs. So it's not just kind of manufacturers want to get a product out there quickly, as everybody wants that product quick as well. So we need to get it out there. And what we're having to do is a lot of kind of simulation, simultaneous engineering. We have to do a lot of work alongside manufacturing, because conventionally, if you follow that 5-year plan that we all used to follow, is you're laying down tooling for your upper body kind of probably 2-3 years before you need to make it. And we're not even started our design then. We're not even started the product then. So we're having to do a lot of work up front with the platform to make sure that there is bandwidth in the platform to match what we believe is going to be required. We can't lay down a target book the same as you normally would with a conventional program and say, we want a vehicle that can do X, Y, Z, and here's the targets for it. We have to have ranges in there. We have to have ability to meet, like I say, different wheelbases, maybe different range requirements, maybe different dynamic stiffness of the vehicle, because it's going to have different applications, and we have to cover that in the whole design at the start. So it's laying down a lot of the requirements at the start for the platform to make sure you can cover the different options as they come along, doing a lot of simultaneous engineering with the manufacturing partners, so you know that when you're going to put a body onto it, we've got the connection points defined, and we know that those have got the loading and the connection requirements that will match a variety of different bodies that are going to go into it. We know that we're looking in terms of weight distribution to make sure that that body is designed and manufactured to make sure that the weight distribution for the platform is going to match what we want for the payload for that vehicle. So for me, it's like any good engineering activity. It's laying down the requirements at the start really early, but having enough bandwidth in those requirements to match where you believe the different options are going to go. You're not designing for one vehicle, you're designing for a platform that can do a range of vehicles.
Yeah, and Cengiz, I mean, coming back to you, when the hybrid started to come through, I remember being on some production lines and the cars ostensibly looked the same from the outside, but talking to the engineers, especially this is certainly in the body structure and the architecture, they were fundamentally different underneath. And and we were talking there, you talked about there a little bit about the challenges of putting multiple variants or platforms through existing body shops. That I think in a discussion we'd had previously, we sort of said that they have always been quite good at being flexible. They have developed flexibility over the years, but now this is a kind of a big step change in what's required of them. And I mean, just looking down at obviously the market trends and demands there around this speed to market. It might sound easy for an existing car maker to make those changes quickly, but it's certainly not. It's expensive and again challenging with the existing footprint. Also, there are challenges around materials choices now as well, because there's an onus on lightweighting. So some companies are dabbling with multi-material mixes. Some of the higher end cars have got those. Also, we have to incorporate the battery enclosures as well, and that's created a headache as well. So from your point of view, where do you see perhaps some of the solutions in being able to streamline those existing body shop flows?
So a couple of the things, actually a lot, not only a couple, what Peter has mentioned just before on the development side of the product, have a big impact on putting the product together to a final product, right? And the manufacturing demand is diversifying in several areas, driven by different powertrain options, but also this then carried out in multiple parts. So carryover parts, like in the older way of building cars, so one platform and then getting a different shell around it, is no longer sufficient on flexibility for main production lines or combined production lines, which again then is increasing the flexibility demands on logistics. That's why we are also now looking into not only being involved in the simultaneous engineering to give our feedback to the development during the development. Hey, is it possible to maybe combine gripping points to have common location areas of different parts that we can combine and simplify the gripping and clamping technology, fixturing technology to manufacture these different parts over one line. Having said that, the logistic part is still remaining. So our task is now extended, not only limiting how the part gets into the production line, but how the rack full of parts is coming to the production line. How many times I have to change those? Do I need double rack provision or single rack provision? We are now developing also solutions together with several OEMs in several areas, which are trying to address all these things. Higher part densities in racks is a big point, because when you are able to double the size of a sheet, single pressed sheet in a rack, then you are reducing the logistic efforts by 50%, right? And these are things we are also now looking at, not only really limited to our core business, which is single-sided clamping technologies and reducing non-value added times in the manufacturing process by streamlining joining processes, but also now really from a way higher point of view, in order to support the highest possible flexibility of multiple powertrain platforms in one manufacturing facility.
Yeah, I mean, one of the things that kind of comes to mind is these kind of processes, the improving speed to market in a body shop. So Peter, you've already talked a little bit about the process of getting a vehicle, which ostensibly might look quite simple, but all the gates and the processes you need to still get that vehicle on the road. The change is there, you know, the challenge around the internal logistics, the actual operational section that kind of factor into that. But I mean, some of the processes we're seeing now as vehicles move forward, so into, let's say, now taking away the kind of the ICE kind of converts, but now into the bespoke vehicles, do you see some of the body shop processes changing or becoming redundant that are already in there? You talked a little bit about joining there, actually, and some of the joining challenges as well. Do you see some of the processes that were existing in a high volume production area in the body shop now no longer being required or as important? So
actually, all the processes which were carried out in the past, let's say traditional spot welding, for example, laser welding, laser brazing, some riveting joining technologies are still there. Yeah? New additional joining technologies driven by materials which are now being introduced into the vehicles are added to this existing portfolio of required joining technologies, which is making the things pretty complicated. For example, running a steel body in white is requiring certain technologies in joining. Adding an aluminum space frame or any kind of aluminum vehicle onto the same line is doubling the efforts, because all the weld guns, resistance spot welding guns, cannot be used for this particular purpose. So you need additional feeding systems for riveting, or aluminum guns, which are way bigger, which are making the flexibility is possible, but the efficiency of the line is going down, because you are losing too much time to change the joining technologies required in one particular station. That's why now the trend is going also in the way that similar platforms, similar material composite cars are used to be built over one line, and some modular areas which are focused on special joining technologies are being created, dedicated for this joining technology. And if a car needs this joining technology, it's just going through the station, and others are following the streamline. So these kind of solutions are now integrated and working just fine, but still there are pros and cons, of course. The con side is that you are increasing the space requirements in any case, because you need additional stations beside the line, parallel, or then at the end of the line, or in new areas for this special joining technology. And you cannot move, for example, if you are welding a bracket which is required in the middle of the main line, you cannot move this particular process to the end of the line, because you have the end of the line joining station, but it has to be in that particular sequence of joining operation. So all this is making the OEMs really think the way to either go completely separate in with the different joining technologies, required platforms and vehicle structures, or really go completely modular.
We're going to come on to a bit about modular production in a minute, but I just wanted to come back to you, Peter. You're working in the LCV sphere there. A lot of the processes we used to see in the traditional body shops, that's probably not the right word, but in the existing body shops, were around aesthetics to some degree. So you're now working in LCV. So essentially, is the priority now shifting more to function rather than fit and finish, shall I say?
I think in an element, yes. I think we've all got a standard. I think there's always a requirement, and particularly with EVs, we need a body structure that allows you to get the benefit of that EV. Because we're looking at maybe different. We're talking about different architectures. We as REE can configure with different wheelbases and actually have the wheels and the steering wheel wherever we like. It's a steer-by-wire system. So it ends up that you can actually have a different cabin or a different structure to what you normally would have conventionally. And then you're actually looking at what's the use case? What do people want from it? And often it's more about how, as an operator, can I get more efficiency from my driver, better working environment for my driver, more security for my goods. There's a number of criteria that are more important to our customers maybe than the aesthetics of. We still want it to look nice. We've still got to have a level of MVH. That means, particularly with EVs, that we're keeping it nice and quiet. But it's not as important to them to have some of the kind of maybe the higher gap finish, the smaller gap finishes that we'd expect on a more premium kind of pass car. Because also we're looking at lower volumes. We're looking at things that are in the thousands, not in the hundreds of thousands. So we need something that can be done quickly, that delivers the functionality really, and that the customer wants. And the aesthetics is a secondary to a lot of our customers.
Cengiz, what's your view on that? Do you think there's a bit of a shift in priorities in that respect?
Time being, temporary, I would say yes, because of the availability of vehicles. Yeah, very simple. Everyone gets what he's able to get, yeah, at the moment. On the other side, it depends really, as Peter already said very clearly, on the customer base. Yeah, there are customers who are very rigorous on quality. I want very fine gap and flush, and others are just concerned about the performance and fashion of the car, or of course the budget they have available. And there's a big difference in requirements. Each individual has different requirements, which again is driving a lot how you are building the car together. The efforts you are putting in, the tolerances, the tolerance chains from the very first station until the end station, these are all quality measures which are affecting everything, the visual optics of the car as well as the price tag of the car. And therefore it is a very difficult question to answer on one side. On the other side, since 20 years, this is exactly what the industry is doing, is following the demand of the end user. Yeah. Introducing, in the previous times, there was a coupe and a sedan, and then there was coming up the station wagon. Then they introduced the cross hatchback, notchback, SUVs became modern, became really very famous on the roads, and small SUVs, large SUVs, and all this is not only having an impact on the product development, but a huge impact on the requirements on manufacturing and final assembly. it sounds that easy, yeah, light commercial vehicles, but we had a project with a facility where literally at the end of the line there were coming out 10,000 of different configurations of one car the end user were able to configure based on his needs. As Peter said, all the arguments, yeah, security for the goods, good comfort for the driver because they are spending a lot of time in it, security here, there, long wheelbase, short wheelbase, double cabin, and so on and so forth. So all these things are nice to have and required to be offered to the end users, but driving, of course, the flexibility requirements in manufacturing and having an impact also, to be fair enough, on time to market. As higher the flexibility is getting as in the manufacturing, as longer typically is the lead time to market.
Peter, do you want to say something?
Yeah, I was going to step in and say one of the other things from an LCV point of view, and also from what we're providing with our technology, is that the durability of the body is an important factor. We're providing a technology, and EV is still in its infancy, so we've still got a lot of new technology that's coming along, and things are evolving quickly. So different battery technologies that we have now will be obsolete in 5 years' time. Motor technologies that we're using now will be maturing, and we've also got the ability to upgrade a vehicle's performance functionality by software. You know, a lot of very much our product is a software-driven product, and what you've got then is you've got the ability to upgrade the powertrain. You've got the ability to, with ours, to swap the corners and put a new generation of corner on it, but the body still needs to be there. The body still needs to be durable. So potentially you can have a vehicle that's got a 20-year life, and we've changed the powertrain twice or 3 times in its life, but you've still got the same upper body. So you need it to be durable. You need it to be something that people can work with, maybe change the trim, maybe update it, but it's got to be a durable product, because vehicles are going to evolve, and they're going to evolve quicker than in the ICE world.
I just want to come back just momentarily. We talked a little bit about, mentioned there about modularity, modular production, and we talked about volumes as well. So still, relatively speaking, EV production, whether it be LCV, whether it be light car, are still relatively low compared to the ICE sort of mass production areas. And I just wondered, there's a lot of discussion, there's a lot of implementation around sort of cellular modular production operations now, the way it's being looked at. And it's been adopted by some of the newer car makers, especially. They've looked at that area of it. Does this process, aside from solving a problem, let's say, or making something work, does it offer other opportunities? Does producing in a lower volume in a modular way offer more opportunities to a vehicle maker? So can I come to you, Peter, on that one, if I may?
So I think for us, we're looking to be. We talk about REE as actually we're assembling vehicles. We're not manufacturing vehicles. So we're actually going through a process of actually working very closely with suppliers to make sure that we've got. We talk about kind of completing. Kind of with suppliers, not competing with them, so we've got something that can work with us. So in the modular point of view, we've made a very much a modular architecture that we can scale the vehicle, and we can scale the performance, be it range, be it speed, be it wheelbase, be it volume. But we can also then take that modularity into the manufacturing process. So we've got an assembly process for our corners, for example, that's got 12 stations, and those stations are to assemble the corner. That can be any size of corner. So we're looking at saying that can do at the moment. We're doing our P7 corner, which supports the kind of 7 class 3 to class 5 in America, the 7 to kind of 9, 10 applications. But it could also be configured to do our smaller corners as we develop them and as we produce them to volume. because we've configured the manufacturing process that the robots and the handling can take a large motor or small motor. I think as Cengiz was saying earlier, you can make it so that your configuration is there. That allows us to make one investment for a number of different applications, and it's unlocking it for us to be able to then produce at smaller volumes, because we're not relying on the throughput of a manufacturing line to give us the volume and therefore the payback on just on one product. We're getting the throughput and the modularity on a number of our different products.
And Cengiz, what's your view on this? Because obviously, you know, you're one of the things that I know Magswitch works on around is footprints of production cells and operations. And what's your view on that sort of that modularity? It's flexible, but is it giving? Are there other opportunities within production? Does it open things up maybe for vehicle manufacturers in that respect?
It definitely does on one side, yeah. But let me give you an analogy. A body shop is nothing else than a machine which is producing a part. You're feeding input, a single parts, and at the end there's coming a body structure. If we are now comparing this with a printer, you're feeding with photo paper to have a glossy image, or you also can print out on a normal paper and you are getting a letter which you are signing and sending out. So essentially, what would be the best? To have 5 different printers for different letters, same size, or you have one multifunctional tool where you're feeding in different medium and you are getting different output. And this is, I think, also a good analogy for body shops. Our goal is, as you mentioned, increase the flexibility in a way that not only the model can flex in production rates, so multiple models. And today, I think it is really hard for sales and marketing of OEMs to determine the really volumes of individual modules and be on the spot, because the sheer amount of different models in body structure is making this very difficult. And giving them the ability to allow shifting volumes from A to B as they go, reducing non-value added times at the same time, and reducing the footprint and the capital investment ideally, and you know, everything what we can contribute to, and a fast time to market for all added models, I think is the better option if you are comparing it again between a multifunctional copy, fax, scan machine versus 5 dedicated devices.
I've got a question here then. You mentioned earlier as well, Cengiz, about sort of variations on an LCV that you mentioned there, that just how many of them there were. I'll come to you on this in a minute. So yeah, I could answer the question from my experience of talking to production engineers to say the question I would have here is too much choice a problem? And most of them would say, yes, it is. But let's take that back. That was a few years ago now. So where we are now at with multiple platforms, with changing market requirements and approaches. And Peter, you mentioned obviously one of the things that one of the USPs actually that REE seems to be working around is that, especially in the LCV thing, is that bespoke approach to it, but still with a utility vehicle. We're not talking a Rolls Royce. We're talking with a utility vehicle. So I'll come back to you, Cengiz. I mean, you can say yes or no, but I mean, is too much choice now a serious problem, given where manufacturers are in managing, trying to flex across these multiple platforms that we're looking at?
It is not a problem, it's a challenge, and a challenge which can be overcome, right? Because at the end of the day, the flexible production line will be it will deliver really continuity and a longer life cycle than building a dedicated body shop for a dedicated model and then after 6 years, 7 years, whatever the life cycle will be of this particular model, taking it apart and building the next generation on the same given space. We have seen, for example, we are working a lot with customers on brownfield, so existing facilities where you have space restrictions, and now the different architectures require new assemblies, completely new sub-assemblies, not necessarily driven by a completely new product range, but the next generation of the vehicle will have different parts, different assemblies, in addition to what it was carrying before, which is requiring additional space. But the space, as I said, is a brown field, which is making things really difficult to justify an investment and stay within the given KPIs on the OEM side. We are always really contacted and asked, hey, can you provide us your support with your view of things to minimize the footprint, increase the flexibility, combine maybe existing commodities together. And I'm not exaggerating by saying it's not only right to left, right long member, left long member combined in one. No, with how we do it, we can combine the right front with the right rear. So completely different assemblies can be run over one combined line. This was just an example. So, and this is where we are really seeing now more and more that these new architectures of products, not necessarily driven on the platform side, but also on the upper body, structural, yeah, as Pete said just before, is something where we are asked to support quite often. And in order to do this the best way we can, we need the involvement really at a very, very early stage, so that we can still have input and a feedback to the product development in order to have common clamping points, in order to have common locating pins, in order to really streamline and simplify the flexibility of a line.
I was just going to, sorry, Nick, I was just going to jump in there because I think what Cengiz just said there about being involved right from the start is the key, because as we go to EVs, we're changing from an evolution of products. So as Cengiz said, you look at existing products and the number of variants you've got will be large because things have been added, and they've been added over a number of years, and things have been changed. And actually with the EV technology, and what it frees up is to start again and actually look at it afresh and say, this is this is revolution. We can start again. We can do something different. And yes, there's going to be lots of choices, but we need to manage those choices, because a lot of people do things because they've always done it. They've always had, a cup holder there, or they've always had a handle there, because that's what they've always had. But do they actually need it? Is it a variant that is actually needed? And I think it is a challenge, and we need to challenge very much at the product level to actually say, come into this, please, with a fresh mind and have a new idea of how you want your body structure to be, because it doesn't have to be as it used to.
Yeah, because I mean, it comes to, you've probably answered the question there. Has EV increased vehicle platform flexibility? And it has. I mean, it's been a driver, hasn't it? I mean, flexibility. I think I remember when we had the back in about 2008, when the economic crash basically floored the sort of the major car players, and one of the things that came out of that was the need for flexibility in their production operations. That was all everyone was talking about in the subsequent years. And now we're moved into the sort of e-mobility era. That just seems to be ramped up even more. I mean, but it seems, as you mentioned there, Cengiz, you were right. It's not a problem. It's a challenge that can be overcome, because that's what you do. You look at something, designing a car, building a car. There are challenges there, and that's what you do to move that forward and evolve. It's not getting rid of something that's not wanted. It's just moving something forward to progress it. And it does seem to have been, from my point of view, or from our point of view, when we've looked, a huge driver, because when we look around and we look across car makers, whether they be newer car makers who have come with a unique or a very different approach to the design and build of the vehicle. So with REE, I mean, the question about is too much choice a problem? You've actually, your concept, the core of it is choice, is flexibility, isn't it? I mean, that's what REE, I remember when I was seeing the initial press releases a few years ago about the corner architecture, and now I'm seeing much more around the body structure and vehicle structure. It's what the USP is, to offer that kind of choice. And I think the conversation I had with you last week was, it looks simple, Peter, making a box on wheels, but I think you pointed out to me, no way is it, because of those choices you were saying that we offer, that are built in, or we build into it, that create that. But again, driving flexibility, you have to build that flexibility into the initial core design of the vehicle.
Yeah, and I think it goes back to what Cheng was saying, and we've seen that evolution in the past car world, where we've gone from 2 or 3 models to 30 different models of a vehicle, and you're starting to see that in the options that people want in the LCV market. There are different requirements for a vehicle that is going to go and deliver in an inner city circuit to a vehicle that's going to deliver on a highway circuit. And that, in the EV world, we can size the vehicle to match its application. We can put the right size battery in it, so you're not over specifying. Whereas in the ICE world, you kind of had an engine that would do both, and you would then try and run it at the right point. So there is a lot more configuration there, and it isn't just as simple as kind of it's a box and you put 4 wheels on it and away it goes. But that's a good challenge, because we're listening to customers. We're actually listening to what people want, and I feel that we can start to deliver products that are more aligned to what actually the use case is, and not, as I said before, not just an evolution of something that's been in the past.
I've got kind of one last question on this that I would like just to, do you want to feedback on what Peter was just saying? I mean, obviously he was commenting on what you said.
Yeah, just one thing, Nick, I wanted to add here. Everything what was just said by Peter and also before is making things drive towards the digital twin, because we heard now a couple of times the sentence, time to market. How can we reduce the time to market? Time to market in a lot of the time spent in building up the manufacturing line is not in design, it's not in manufacturing, it's really in installing and commissioning, and then tryouts, different phases of the product build. And the digital twin with virtual commissioning and material flow simulations, in order to handle the complexity, including logistics, including the complexity of the entire orchestra of automation, is making the need of this digital twin really very, very important. As more we go in this direction, as higher the diversification of the models, using one common platform, like in the case of REE Automotive, with different shells around it, coordinating all this and dirigenting the orchestra is, I think, something which will be very, very important in the near future, in order to not jeopardize program length, program timings, and really SOPs, that everyone gets the car he wants.
we're going to come on to digital stuff a little bit later on. But one last question I kind of wanted to ask you both. I'll come to you, Cengiz. I know you've just been chatting, but question is, are micro factories the future? Because we've read a little bit about micro factories over the last few years being established for bespoke, relatively low volume, particularly localized production operations. What's your view on that, Cengiz?
So I see this as definitely a viable future. Yeah, looking at the entire global situation with supply chain, with everything, really, it might be worth into spending thoughts. To be honest, yeah, I have not digged into it that much, but I like the approach of this micro factories, because this will focus the capacities where they are needed. Yeah, more regional demand. By regional, I mean, for example, Europe, or even country-specific locations where certain cars for this particular country are built, instead of having one central facility which is spitting out 500,000 of vehicles a year, which is concentrating a lot of supplier base around it, which is consuming really a lot in a very concentrated area, rather than, let's call it, decentralizing the entire manufacturing in micro facilities. So I see it as a viable option for the future, because it would also be a kind of copy and paste thing, right? What's happening is you are terminating, and you are really terminating without any additional thing you are adding to it, all the non-value added times, because each cycle, from cycle to cycle in the manufacturing build of a car, is reduced by X% because of the handling of the part from A to B. And if you are having multiple locations which are producing in total this amount of cars, then you are eliminating the amount of stations which you need to handle the car A, B, C, D. So the entire production lead time goes down and the efficiency goes up. So there are pros and, again, cons. Yeah, because you have to establish the skill set in multiple locations. You have to, control all the quality, everything in multiple locations. There are pros and cons.
Peter, what's your view on it?
Yeah, I think I think the same thing. I think there's a lot of legs to this. I think it needs to be managed, and I think you need to. For example, we're trying to start off by making sure that we can manage it in a very containable way. So we've got an assembly, like I said previously, an assembly process, not a manufacturing process, that allows us to have that as a configurable and blueprintable option to move to different regions. Because as you go to EVs, one of the things is batteries are very, very heavy. And when you look at a platform and you want to be producing a platform, you don't want to be producing a platform in one location and spending millions of pounds on logistics to transfer a battery to another location, having spent millions of pounds to transfer that battery to your factory in the first place. So you've got to be closer to a lot of your key commodities, and you need to have more ability to do that. So we're seeing it as a way of scale as well, because we can, for example, we are based here in the UK. We've got our engineering centre right next to our first microfactory or integration centre, and that then allows us to get all the knowledge of the engineers alongside. We talked about the simultaneous, we talked about the manufacturing engineers being really involved from day one, so that you get that honed and you get that model together. Then you can copy and paste, and then you can put it elsewhere. But you've got to get that first step right. You've got to have a launch factory, as we call it, to make sure that absolutely that first one gets it right. Otherwise, you just spread the problem over lots of different places.
I'll just thanks, Peter. It's an interesting one, the microfactory, because it seems very, what Shinga was saying there, it's very counterintuitive from how the industry has been developed for decades, really, around bringing centralised, large-scale supplier parks and things. But it's a very interesting concept, and as we've been talking about, this need for flexibility and for a readjustment of things, it like you say, it could play a very strong part in that. It'd be interesting to see going forward where that develops. I'm very conscious that we're getting very close to the end of time with this. I do have a question from one of our audience members. This moves back. I think you can both offer some insights into, obviously, you're both experienced. Based on the production technologies and materials available today that we're seeing now, the levels we're now attaining. This goes back to, this is a materials related question. how practical is it to have a full CFRP body on frame for mass production and high volumes? Because we kind of have probably seen those in low volume sports cars and sort of high end. You tend to see that, but you were talking, Cengiz, if I can come to you first, because obviously you mentioned sort of joining multi-materials, and there are challenges at doing things at volume and at speed, isn't there, at scale? So where do you think though now with the technology you're seeing, is that a viable option for I'm guessing an entry segment sort of car maybe?
Mm-hmm. So we have seen this in the past with a German OEM who has built carbon fiber body structure, which required completely new skill set also of the operators, which required completely new processes, which nobody really in the automation world ever done before. It was managed then afterwards. It took time, but quality of the final product was given. The results were okay. I mean, good, not okay. Don't get me wrong. It was good vehicles, yeah, but it never made it to really mass serial production. And there is one particular thing which is driving even the abandonment of potentially aluminum as a material for mass production, which is the carbon fiber footprint of the OEM, of the car, of the model, because it's not only the consumption which the end user is putting on the road, let's say, how much kilowatt hours per 100 kilometers, or how much liters per 100 kilometers, but also the entire supply chain from starting creating the material until really delivering the product, including then recycling at end of life. So all this is contributing to decisions which are taken by the OEMs, which have to be taken by the OEMs. And this might be a big driver of the fact that carbon fiber as a full body material has not made it to a really mass production.
Yeah, that's an interesting angle on that as well, because that has been a bit, even if you can join the stuff, make it, and the material can be quite cheap even potentially, then it's, as you say, there are factors like that which it doesn't take much just to stop it sort of breaking through. I mean, Peter, what's your view on that? I mean, I know you worked at Lotus, so you might have some experience.
Yeah, I mean, lightweight's at my heart, so I'm always keen on things like, you know, when we talk about carbon fiber, and it's all important with every EV, but it's, again, it maybe goes back to, Cengiz said that you've got new processes, you've got new factors, you've also got to think about new finishes. I mean, when you work on a carbon fiber body, you're trying to get your paint finish and trying to get all of the quality finishes onto that is, Cengiz will tell you, that's the challenge that goes with it. So it's a great technology, and if we can solve the cost side of it, and if we can solve the manufacturing side of it, we've still got a lot of perception changes to it. You know, when I've looked at it previously, like I said in the previous slides, that it's the quality of the finish that actually takes so much time to try and get close to where a conventional kind of steel structure or aluminium structure vehicle will be in terms of paint finishes, etc. So yeah, we need to be looking at advanced materials. We need to be looking at light weighting, because I think it's the only way to make things more efficient. But I think we're quite a way away, if I'm honest.
And it depends how much focus there's been on, because the materials are kind of there, and some of the processes we've got very good with adhesives, rivets, etc. in building it, and quite quickly as well. It can be all automated, but it's how much focus is at the mass production end. And as you say, there are some steps still to go yet before it becomes, no one wants to add more hours to the jobs per hour kind of thing in any respect. So that's kind of a big no-no in that respect. I've got just one more question, because I want to ask this one, because I think it's quite an interesting one. It's just come in. So let me read this out properly. So there we go. Sorry. Is it? So the question is around sort of the fact that battery vehicles are now essentially, the battery is the kind of hub of it, if you like, is kind of has been the focus of attention. So then you're getting sort of mass customization. The question is mass customization of a vehicle, or perhaps its ability to be mass customized, you know, is that becoming a commodity now? So the build on accessory of equipment, the usage of the mobility as a business model. I have seen this. I'm not going to say who with, but I have seen this with at least one example of a company that's kind of made that a very, what's the USP of the vehicle is the fact that aftermarket add-ons never used to really add much to a vehicle, but actually now would be its ability to be transformed, its ability to add on to even alter its use case quite drastically would be possible. Do you see that as do you see it as a commodity, and do you think we're edging towards that, or is that somewhere again far away kind of thing? So James, I'll come to you with that one. That's a.
Of course, it's a business opportunity, yeah. But I can not imagine how to make it in a scale, to be honest, that you have such a customizable base that you can get this one to the specialist who can then do whatever the end user really needs and wants. Of course, it would make things pretty easy for OEM, yeah. If it would be possible to come up with a design which will allow the add-on customization. I was also on the tuner scene back in my days, and you can compare it with essentially that, right? Wider wheelhouses, different alloys, and all that, yeah, but in a mass production and very much tailorized. The base is, I think, where a lot of time and brain would need to go in order to develop something on a product side which will allow the external customization, even without the shell. I could imagine even that the shell is not existing. Yeah, it's just the body structure, and the shell is then designed and attached to the structure in a different place by a different company. So I could definitely, I like the idea actually.
Pete, what's your view on that?
I think as I said earlier, you know, we're looking at commoditizing maybe the software configuration already. So that if you got over-the-air software, you can actually look at making the performance of a vehicle better. You can look at adding features into the infotainment. You could do a lot of things customizable in the software world. We're very excited by this because as REE as a platform, it goes into the ethos of what we're trying to do. And we're looking at a number of different concepts for the future where that whole upper body is configurable. So actually, you may have a platform that has 4 different bodies. And we're looking at some uses with some customers where even with an autonomous platform, you can have maybe 4 different bodies on that vehicle in one day. So, you know, it could be a school bus in the morning, it could be a refuse truck in the afternoon, because we're going to work towards making products or vehicles more efficient, because the platform and the battery is going to be the expensive bit. In some ways, if we can make very cost-effective top hats, it's like a kid's toy. You can put different ones on it every day.
It's a very interesting. It was an interesting, because I hope I got that across properly for the question poser. But it's an interesting, because we are seeing there are other things about buying cars and dealerships and things. Lots of business model things about how they're going to change. Vehicles being owned by the OEM, and you just essentially lease them, and they have them back for refurbishment. So they're designed with a view that they can be upgraded rather than kind of scrapped and starting again. And it's an interesting one. I have come across it where the kind of the IP was all around kind of the customization of the vehicle, in the sense of, and you mentioned there actually again, probably something quite unseen, but the commodification, is it commoditization of things like software? I mean, people are making their software, then licensing it out, because it's like, platform sharing going across now. All these things take time, and I know, speaking to you, Peter, we haven't had a chance to go on to that, unfortunately, but developing a core software, control software, that is transferable across platforms, that can be fine-tuned and updated, but like the corners you have, provides the foundation of an architecture of a type. So yeah, it's an interesting one, and vehicle bodies are an interesting one, because I always think there are certain parts of the vehicle that often get kind of overlooked. It is what it is. But when you look in more depth, there's complication, there's variation, and there's opportunity with it. I think it's been really interesting talking to you this afternoon and getting your views on production trends. We've covered quite a lot of ground, guys. I know there was a lot more we would like to. We could do another hour probably, but I'm not allowed to do that. So, and I'm sure we need to let Cengiz get back to his meeting with Volkswagen fairly promptly. So I'm going to say, thanks guys for joining me. I'd like again to thank our sponsors, Magswitch. Great appreciation for their support with the live streams, and providing Cengiz as well. He talks to me a lot these days. It seems almost as much as his clients probably do. You'll be able to find this live stream recording on our website in the next couple of days. So just visit the website. We'll be putting out some information across our newsletter and on our website where you can find it. So the recording's there, along with all our other live streams. And some biggish news for us this year is, there you go, there's a QR code there. You can scan that, so you can find where the live streams all are. And some big news is that, for us certainly, is that AMS is going back to live in-person events. I think the last one we did was back in 2013, as I recall. I think the last one was in Detroit, and then we moved on to doing something different. But with COVID getting in the way, that's stalled things. But we're now back. So we'll be doing a one-day event in Munich on 6th of December. We have speakers from Audi, BMW, Ford. We have CATL battery makers. We had ZF from the tier suppliers, and many more. So if you want to click onto the QR code there, you can register and you can find out who's speaking and what sessions there are. There is also going to be, so you can either watch, I think we're live streaming or recording it, so you can register for that, or you can attend in person, which would be great to meet some of you. We're also having a tour around BMW's Munich plant. So they are currently preparing the plant, or well into now, preparing the plant for the newer Classer platform that they're about to put out. So perhaps a chance to get a glimpse at what BMW are doing, and the knowledgeable of you will be able to look at that. I'm looking forward, hopefully myself, to getting a tour around there at the same time. So please have a look at that, and if you're interested, definitely register, and it'd be great to meet some of you face to face. So with that, I'm going to say thanks very much to Peter and Cengiz again. Yeah. Stuff, guys, thank you very much for your time, much appreciated. To all our audience, thanks for joining us, and look out for our next live stream and our future events. Thanks and goodbye.